My dear learners, I, Yakubu Fidelis, welcome you again to another segment of our lessons. God willing, today we are considering a subtopic in indices known as the indicial or the exponential equations. Definition. The indicial equations are the equations involving powers, or otherwise known as the exponents, where the values of the unknowns are to be determined by applying the fundamental laws of indices. E.g., x to the power of 1 over 2 equals 4. X there represents an unknown. Next, a to the power of x equals 32. X is also an unknown. A to the power minus 2 equals 9, where a is an unknown. 2a to the power minus 3 equals to 54. In this case, a is also an unknown, etc., etc. Before we go further to see practical examples, my dear students, before we go further to see practical examples, it is very imperative to note or to recall the fundamental laws of indices. And also note that presentation in indices are preparing you towards effective answering of questions involving indices in WAEC and NECO. Here are the practical examples. Solve the following equations. 1. 2x to the power of 3 equals to 54. We are to determine the value of x there because it's an unknown. 2. 4 to the power of c minus 1 equals to 64. C here is an unknown. 3. 9 to the power of 2x plus 1 equals 81 to the power of x minus 2 all over 3x. Our x here is an unknown. 4. 2 to the power of 1 minus y multiplied by 2 to the power of y minus 1 all over 2 to the power of y plus 2 equals 8 to the power of 2 minus 3y. And 5. 2 into 1 over 8 to the power of x equals to 32 to the power of x minus 1. My dear students, from the examples, we can now see that in number 1, x is an unknown, so we are to determine the value of x. In number 2, c is an unknown, we are to determine the value of c too. In number 3, x is an unknown, we are to determine the value of x. And in number 4, of course, y is our unknown, we are to find the exact value of y. And number 5, x is our unknown, we are to determine the value of x. Solutions. Question 1. 2x to the power of 3 equals 54. Divide both sides by 2. So that becomes 2x to the power of 3 all over 2 equals 54 all over 2. We divided both sides by 2 because 2 is the coefficient of x to the power of 3. So when we divide both sides by 2, it gives 2 and 2, 2 in the numerator over the 2 in the denominator is gone. So we are now left with x to the power of 3. And on the right-hand side, 54 divided by 2 gives 27. So the equation becomes x to the power of 3 equals 27. Then the next step is to take the cube root on both sides. And that becomes bracket cube root of x all raised to the power of 3 equals cube root of 27. And cube root of x, bracket cube root of x all raised to the power of 3 can be written in an exponential form as x to the power of 1 over 3 times power 3 equals to the right-hand side, which is the cube root of 27. When you simplify x to the power of 1 over 3 times power 3, it becomes 1. What I'm saying, 1 over 3, the power of x, times 3. By simplification, you are going to get 1. So, and when you look at the right-hand side, the cube root of 27, which simply means what number can multiply itself 3 times to give you 27? And that number is 3. So that finally gives x is equals to 3 as the correct answer. Question number 2. 4 to the power of c minus 1 equals to 64. 4 to the power of c minus 1 equals to 64. Left-hand side, 4 to the power of c minus 1 equals to 4 to the power of 3. Because the right-hand side, which is 64, can be expressed in an index form as 4 to the power of 3. That is 4 times 4 times 4 gives 64. So that gives us now 4 to the power of c minus 1 equals to 4 to the power of 3. And of course, 4 and 4 is gone. You are left with c minus 1 equals to 3. So we are now going to collect the like terms. By collecting the like terms, we can now have our c equals to 3 plus 1. And finally, 3 plus 1 equals to 4. So that finally gives c equals to 4. There is an alternative way of working it. 4 can be written in index form as 2 to the power of 2 multiplied by the power c minus 1. That is the left-hand side. Equals 64 can also be written in an index form as 2 to the power of 6. By removing the bracket of the power on the left-hand side, we are going to have 2 times c. That will give us 2c. 2 times 1, that will give us minus 2. So the left-hand side becomes 2 to the power of 2c minus 1 equals 2 to the power of 6. 2 and 2 is gone. We are now left with 2c minus 2 equals to 6. By collecting the like terms now, we are going to have 2c equals to 6 plus 2. And of course, 6 plus 2 equals to 8. So to find c, we are going to divide both sides by the coefficient or the multiplier of c, which is 2. So that becomes 2c over 2 equals to 8 over 2. And 8 divided by 2 equals to 4. So we can now see that the alternative method result agreed with the first method equals 4. Number 3, 9 to the power of 2x plus 1 equals 81 to the power of x minus 2 all over 3 to the power of x. 9 can be written in index form as 3 to the power of 2. Implies 3 times 3 gives 9. Into 2x plus 1, that is the left-hand side, equals an 81 on the right-hand side can be written in index form also as 3 to the power of 4 into x minus 2 divided by 3 to the power of x. By removing the bracket of the power by removing the bracket of power 3 on the left-hand side becomes 2 times 2x give us 4x, and 2 times plus 1 give us plus 2. So the left-hand side becomes 3 to the power of 4x plus 2. And also, by removing the bracket of power 3 on the right-hand side, it becomes 4 times x gives 4x, and 4 times minus 2 gives you minus 8, divided by 3 to the power of x. And by simplifying the right-hand side, we can see that 3 is the common base, which obeys the second law of indices, that is division. So we have to write the common base, which is 3, and subtract the what? The powers. So that becomes 3 to the power of 4x minus x minus 8. And the equation becomes now 3 to the power of 4x plus 2, the left-hand side, and the right-hand side becomes 3 to the power of 3x minus 8. We can see that 3 and 3 is gone. We are left with 4x plus 2, that is the left, equals to 3x minus 8, which is the right. So we have to collect the like terms. That becomes 4x minus 3x equals to minus 8. When plus 2 crosses, that becomes minus 2. So 4x minus 3x give us x, and minus 8 minus 2 give us minus 10. So the value of x finally becomes minus 10. There is also another way that we can work this question, and the way implies we are going to multiply both sides by 3 to the power of x. in order to remove the denominator 3x on the right-hand side. So by doing that, we are going to have the left-hand side becomes 9 to the power of 2x plus 1 multiplied by 3 to the power of x, and the right-hand side becomes, there is an equality sign that is missing there. There's an equality sign that is missing there. So the right-hand side becomes, it becomes 81 to the power of x minus 2 all over 3x, also multiplied by 3 to the power of x. By simplification, the right-hand side, you can see that 3x divided by 3x is equals to 1. So 81 to the power of x minus 2 divided by 1 becomes 81 to the power of x minus 2. So the equation becomes 9 to the power of 2x plus 1 times 3 to the power of x, that is the left-hand side, equals 81 to the power of x minus 2, the right-hand side. So 9 can be written as in an index form as 3 to the power of 2, as explained earlier. So that becomes 3 to the power of 2 into 2x plus 1 times 3 to the power of x, the left-hand side. And your right-hand side, 81, of course, can also be written in an index form as 3 to the power of 4 into x minus 2. So when you look at the left-hand side, it obeys when you remove the bracket from the left-hand side, that becomes 2 times 2x gives you 4x, and 2 times 1 gives you 2. So that becomes 3 to the power of 4x plus 2 times 3 to the power of x equals 2. And when we also remove the bracket on the right-hand side, that becomes 4 times x gives us 4x, 4 times minus 2, that gives us minus 8. And of course, the left-hand side obeys the first law of indices, where 3 is the common base. So we are going to write the common base and then sum up the powers. So that becomes 3 to the power of 4x plus 2 plus x equals to the right-hand side, which is 3 to the power of 4x minus 8. And of course, 4x plus x, that gives us 5x, then plus 2 there. So that becomes 3 to the power of 5x plus 2 equals to 3 to the power of 4x minus 8. And of course, you can see 3 and 3 is gone. So you are left with 5x plus 2 equals to 4x minus 8. At this point, we are to collect the like terms. By collecting the like terms, we are going to have 5x minus 4x. Because when plus 4x crosses to the left, the sign changes. That's why it becomes negative 4x there. And also look at the positive 2 on the left-hand side. When crosses to the right, becomes minus 2. So the right-hand side becomes minus 8 minus 2. And when we simplify this, 5x minus 4x, that is equals to x. And minus 8 minus 2, that gives us minus 10. We can now see that the first method, the second technique, result agrees also with the first technique, which is equals to minus 10. Question number 4. 2 to the power of 1 minus y multiplied by 2 to the power of y minus 1 all over 2 to the power of y plus 2 equals 8 to the power of 2 minus 3y. We are going to simplify the numerator. The numerator obeys the first law of indices, which is multiplication. And we are to write the common base and then add up the powers. So the common base there is 2. 2 is written. By adding up the powers, we are going to have 2 to the power 1 minus y plus bracket y minus 1. Bracket is essential because it could affect this. It could affect the sign. If that plus were negative, automatically the negative sign in the bracket would have been affected. So bracket is very, very paramount there. So, and all over, so that becomes 2 to the power of 1 minus y plus bracket y minus 1. So all over 2 to the power of y plus 2. And the right-hand side, 8 can be written in index form as 2 to the power of 3. Because 2 times 2 times 2 in 3 places, that gives you 8. Today, so we now have 2 to the power of 3 into 2 minus 3y. Now, by removing the bracket, the left-hand side becomes 2 to the power of 1 minus 1 plus y minus 1. Then divided by 2 to the power of y plus 2. And when we remove the bracket on the right-hand side, which implies 3 times 2 gives us 6, and 3 times minus 3 gives us minus 9y. So, if we look at the left-hand side, the left-hand side obeys the second law of indices, which is division. So, we are now going to write down the common base and then subtract the what? Subtract the powers there. So, in simplification, we are going to have 2. When you simplify 2 there, the power of 2 there, that becomes 1 minus 1 is equals to 0. And minus y plus y is also equals to 0. So that gives you 2 to the power of 0 plus 0, which will give you 2 to the power of 0. Divide by now 2 to the power of y plus 2 equals to the right-hand side, which is 2 to the power of 6 minus 9y. So the left-hand side obeys the second law of indices, which is division. We are going to write the common base and then subtract the powers. The common base there is 2. So we are going to say 2 to the power of 0 minus bracket y plus 2. Bracket is very, very essential. Take note. Equals to the right-hand side 2 to the power of 6 minus y. By removing the bracket on the left-hand side, we have minus 1 multiplied by y. That will give you minus y. And minus 1 multiplied by positive 2, that will give you minus 2. So the left becomes 2 to the power of 0 minus y minus 2. And the right remains the same, 2 to the power of 6 minus 9y. And of course, you can see 2 on the left and 2 on the right is gone. So you are now left with 0 minus y minus 2 equals to 6 minus 9y. And when you simplify, 0 minus y minus 2, that becomes minus y minus 2 is now equals to 6 minus 9y. So let's collect the like terms. We are going to have minus y negative 9y crosses to the left, become positive 9y. And y minus 2 crosses to the right, become positive 2. So by simplifying the left, minus y plus 9y, that gives you 8y. And also simplify the right, 6 plus 2, that gives you 8. So we have to divide both sides by the coefficient of y in order to determine the exact value of y. So, and the coefficient of y there is 8. So we have to divide both sides by 8. So 8y divided by 8, that gives you y. Because 8 divided by 8 is 1. And 1 times y is equals to y. That is the left. And 8 divided by 8 is equals to 1, which is the right. So our value of y here is equals to 1. There is a second technique also in working this, which implies we are going to multiply both sides by 2 to the power of y plus 2 in order to eliminate the denominator 2 to the power of y plus 2, which is on the left-hand side. So by so doing, we are going to have bracket 2 to the power of 1 minus y times 2 to the power of y minus 1 all over 2 to the power of y plus 2 multiplied by 2 to the power of y plus 2 gives 8 to the power of 2 minus 3y, also multiplied by 2 to the power of y plus 2. By the second, on the left, you can see that 2 to the power of y plus 2 on the numerator divided by 2 to the power of y plus 2 in the denominator gives you 1. So the left-hand side becomes 2 to the power of 1 minus y times 2 to the power of 1 minus 1. And the right-hand side, 8 can be written in an index form as 2 to the power of 3, as explained before. So that gives you 2 to the power of 3 into 2 minus 3y, multiplied by 2 to the power of y plus 2. By removing the bracket of power 2 on the right-hand side, we are going to have 3 times 2 give us 6, and 3 times minus 3y, that gives us minus 9y, multiplied by 2 to the power of y plus 2. So now, when you look at the left-hand side, it obeys the first law of indices, where we are going to write the common base 2, and when we sum up the powers. So we can see the common base 2 there is written, and by summing up the powers, we are going to have 1 minus y plus y minus 1 equals to the left-hand side. The right-hand side also obeys the first law of indices, which is multiplication. And the common base there is 2. So we write 2 as the common base, and we sum up the powers, which is 6 minus 9y plus y plus 2. So by simplification of the powers on the left-hand side, 1 minus 1 gives us 0, and minus y plus y also gives us 0. So that gives 2 to the power of 0 plus 0 gives you 2 to the power of 0. And also by simplification of the right-hand side, we can now see that 6 plus 2 equals to 8. And minus 9 plus y will give me minus 8y. So there becomes 2 to the power of 8 minus 8y. So 2 on the right and 2 on the left is gone. So we are now left with 8 minus 8y equals to 0. And by collecting the like terms now, we are going to have 8y is equals to 0 plus 8. And that gives me 8y equals to 8, because 0 plus 8 equals to 8. So to determine the value of y, we also divide both sides by the coefficient of y, which is 8. So when you divide that, 8y divided by 8, that will give you what? Y. And then 8 divided by 8, that will give you 1. So our y is equals to 1, which concords with the first method. Y is equals to 1. Question number 5. 2 into 1 over 8 to the power of x equals 32 to the power of x minus 1. Now, it can be written as 2 into 2 to the power of minus 3, because 1 over 8 can be written in an inverse form as 2 to the power of minus 3, then multiplied by power x. Then 32 can be written in an index form as 2 to the power of 5. So that gives us 2 to the power of 2 into 2 to the power of minus 3 times x equals to 2 to the power of 5 into x minus 1. And that becomes 2 to the power of 1. The power of 2 there is not written on the left, but mathematically it is 1. So that's why I wrote it 2 to the power of 1. Then minus 3 times x, that gives you minus 3x. So that becomes 2 to the power of 1 times 2 to the power of minus 3x equals to, remove the bracket also, on the right-hand side, 5 times x gives you 5x, and 5 times minus 1 will give you minus 5. So we now have 2 to the power of 1.